Yeah.
Because here is the point where our experimental data and experimental began. These are some pictures of our equipments that we have used during our experiment. The first video in which you can see the cell. It's a 5 by 5 centimeter size cell. You can see the zinc plate and the graphite rod, and here is the reaction is going on. Second picture is the two devices that we have used. The first one that shows number on display is the charging device, and the other one is a discharging device. So for zinc battery and aluminum air battery, we used both devices. And first we started with 2 molar concentration. We charge our battery for 15 minutes at 10 volt and 400 milliampere. Then we discharge using this device. That we perform same for 2 molar, 4 molar and 6 molar in zinc air battery as well as in aluminum air battery. Next slide please.
So here is the aluminum plate corrosion. It's for the 6 molar solution. So what happened in the all batteries, like whenever it's dispose of any charge, like it's giving any voltage or any current, it will be like some degradation over the anode side. So this will same happen here, but I want to show you this picture is because of we use the membrane between our shell. Can you put back the slide? Okay. We use the membrane between this anode and the cathode, between this area, and we are using the polypropylene membrane and the cellulose membrane. We have all the both data for the cellulose and the polypropylene membrane one, and on the both one, the cellulose is the best one. I will show you after that. But here there is an aluminum plate. It's before the reaction. Like when the aluminum plate is like non-reaction, like it's when the new one. There's the first photo is for the fresh aluminum plate microscopy, and the second one is without the membrane. You see over there, it's completely dark. There is no place for the reaction going on here, and for the second page it's with the membrane. Actually it's with the cellulose membrane for picture, and here you can clearly see that there is a one black spot. It's all the already reacted parts for the aluminum plate, and it's now after that it's not reacting now. But here there is many space here, better than the without the membrane one. So that means the aluminum plate has still has more potential to give the more power with the membrane. So like our conclusion according to this analysis, like with the membrane, our battery lifespan will be increased whenever we use the membrane, but it has to be like standardized, like in the porous size, or like what type of membrane we are using in there. It's like when we are using the polypropylene membrane, and it's actually a hydrophobic membrane. So with the hydrophobic membrane, it has very lower porous size, as well as it's like repellent to the water or any electrolyte solutions. So we need more power to charge the battery. I will show you after that. The next slide.
So the result, so when it comes to result, I can say that they are quite unsatisfying, but though we are happy because something is better than nothing. So here is the plot of power chart. As I said earlier, like we perform and we analyze battery in 2 molar, 4 molar and 6 molar, all 3 concentration. But what we got, the 6 molar concentration in which battery performs better among all concentration. So here is the power chart of that performance. You can see the 3 trends. The blue one is for without membrane, red one is for cellulose when we use cellulose one, and the green one is for polypropylene membrane. So here you can clearly see that when we use the polypropylene membrane, the voltage drops too immediately, while in the case of cellulose one, we can see it's like it performs better. So after that we concluded like when we use cellulose membrane, battery performs better. It gives a better lifetime as compared to without and with using polypropylene membrane. And then for further testing, we did not go with the polypropylene membrane. We just tested with without membrane and cellulose membrane.
So here, as Vishal said, we are not using the polypropylene membrane for the aluminum plate. It's because of when we are using the polypropylene one, we need at least 3 times more power to charge our battery. It's like currently we are charging our battery at the 10 volt and the 400 milliampere. But when we are using the polypropylene, it's because like his repellent nature, we need like more power to surpass the barrier between the like our anode and cathode. It has to be passed from the porous side. So that's why we are not using the polypropylene for the next aluminum add batteries. So here there is a plot for the 6 molar, and it's the best we got for the 6 molar KOH with the aluminum add battery. We got like about 25% energy density. We are thinking about to have like 100% energy density in our experiment. That's what we are expecting, but in the reality we got only 25% energy density. It's not that good, but still we have some data, and I'm saying like it's not a trustworthy data because we don't have much time to like reproduce our all data. So it's just a one-time experiment, and that's what we got. But if it goes well, I'm pretty sure about like if we have more time, like at least like more 4 months, then might be we can make all data will be reproduced as well. Here the 6 molar KOH aluminum air, and here you can see the blue one. It's without membrane. This trend is for the without membrane, and you see that the power is much more higher than the cellulose one. It's because when we aluminum plate is self-reactive in the electrolyte solution, so it is degrade very fast. Like it's create the carbon layer on the aluminum plate, and it's very fast. And actually, after when the all carbon layer generate on the aluminum plate, after that it's non-reactive. Battery is not charging or not dispose any of the charge from the batteries as well. So for the cellulose membrane, we need some standardized cellulose membrane, like about a micrometer size porous size, standardized one. And actually the cellulose one we are using only filter paper, and it's about millimeter size of the porous. I'm not sure about the what type of porous in the cellulose one, but when we are using actual membrane, at least we need the micrometer size the membrane. Next slide. So and here there is an interval plot, and it's for the 2, 4, and 6 molar with membrane and without membrane. This data is only and only for the cellulose one. We are not proposing any polypropylene one because we made our decision for that. And this data is for the aluminum and the zinc both as well. Actually, it's data for the aluminum, but we compare our aluminum and zinc data as well, and it's almost the same. And you are clearly seeing that like increasing the concentration, our power will be increased as well, because this data is compared to the voltage and current, and it's compared to the concentration as well. So this interval plot shows that 6 molar concentration with the electrolyte solution, it gets more power. Actually it's better than the 4 molar as well, but the 4 molar as might be as I'm saying, like aluminum is self-reactive. So here in the 6 molar, the battery lifespan it will be decreased, but it gives the more power in the 6 molar one. And next slides will be covered by Deepak and Riddhi.
Thank you, Murugesh and Vishal explained all very well. So, hi guys, myself Riddhi Desai and he is Deepak. So, we all know that in science, without the problem and challenges, we cannot get accurate results. So, we have started getting problems when we started the project. The first, we have faced a leaking problem in battery cell.
So to overcome this, we use duct tape. We just put it around the cell battery and cell body, and we overcome this problem.
Then after we have faced the pressing problem. So the first one we have faced the graphite flakes didn't adhere.
So to make a mesh, like we have to make it slurry, and flakes doesn't work well for us, so we use graphite powder.
And then after we have faced the oxidation of steel mesh.
That's because of overheating, so we reduced the time in furnace. Earlier it was for 1 hour, now it was like 45 minutes.
And the most difficult one was the dissolution of graphite layer into electrolyte.
Okay, so what happened during the reaction, graphite slurry went into the electrolyte, and goes to the anode, so that corrode the anode more fastly. To overcome this, we remove that step and we use graphite rod.
Next slide.
Okay, conclusion. So to conclude everything, we have to go step by step. First is like with membrane or without membrane. So without membrane, our results are better as compared to with membrane because electrons are getting towards the electrode very fast. But at the same time, we got the result that the oxidation rate is very high. So we have to use membrane. In membrane, we use two types of membrane: cellulose and polypropylene. With cellulose, results are better, or we can expect some good news from the cellulose kind. But polypropylene, it doesn't give us successful results. The result can be like because it increases the resistance. It has hydrophobic nature. It resists the ions to move. So yeah, and the last one is zinc and aluminium. For the aluminium, we are getting better results because it has 3 electrons, more energy.
So now we will explain future aspect. So reproducibility, regeneration and trustworthy. So you all know that Mrugesh and Vishal has explained that we all got the data with all conditions, but we can say that it's not trustworthy.
Next one is membrane. As we know that membrane plays a crucial role in the movement of ions. So standardized like pore size which fit according to our electrolyte ions, that should be necessary for overall performance of the battery.
Now we have used the two, we can use the two additives in the future like fluorinated ethyl acetate and silica gel. Here I am going to explain first one, fluorinated ethyl acetate. We all know that this one is used in lithium battery and it's for to break down oxide. So we have concluded that it might be useful in the future for our zinc and aluminum battery to break down oxide. However, we can use the silica gel as well because silica gel is a kind of non-reactive solutions, and the solution has been benefit for increase the density. So I think these two additives will helpful in the future.
And the last aspect is electroplating. It's the process where we deposit some inert layer on the anode and it reduces the rate of corrosion, and for that we can use silver. Thank you.
Thank you everyone.